Welcome back, everybody. Here is another example of a composite function where we have the outer function given. F of x is given, and then we have the composite f of g. So keep in mind that our g of x function is going to be going into f of x, and our answer should be that 2x minus 3 over x plus 4. So when we do this, we can simply use a u substitution. I like to use u equals g of x. That's my most convenient substitution, and it will look like this. I'll put that u into my f function here, and so it's going to be u plus 1 over u minus 2. And the answer, when we plug that in, should be 2x minus 3 over x plus 4. Now this is not too bad. In this particular case, we can see that by cross multiplying, we get u plus 1 multiplied by x plus 4 is equal to u minus 2 multiplied by 2x minus 3. Let me just crank this out for you. This is ux plus x plus 4u plus 4, and that's equal to 2ux and then minus 4x, and where am I here? Minus 3u and plus 6. All right, we've got a little bit of work to do getting all these things together, but let's try to collect our u values together. And I see an x here with a negative 4x, so that'll make a 5x over there. I've got a 4u here. I'll bring all the u's to the right-hand side, so I'll just put an equals over here. Looks like this 6 can move to the left-hand side. That's minus 2. And on the right-hand side now, I've got a 2ux, u minus ux, so that's just going to be ux, and then my minus 4x, excuse me, my negative 3u, and the plus 4u gives me a minus 7u. All right, that's kind of a mess, but at least now we see that u can be now factored out. I've got x minus 7, and that's a 5x minus 2. So u equals 5x minus 2 over x minus 7, and that represents our g of x, right? So that's a good way to find that one. Very quick and easy way to find that based on a u substitution. Now the second part of this is this property that we talked about a little bit, and it's a special property of composites that's not going to be proven. We're simply going to use it, and we're going to try to verify this property, which says that the inverse of the composite is equal to the composite of inverses, but it's in reverse. Notice that's in reverse there, that g inverse of f inverse of x. So we're just going to do this with a couple of lines. F of x is equal to 3x minus 5. G of x is equal to 2x plus 7. But we have to find a lot of things here. As you can see, this second part is g inverse of f inverse of x. So that means we're going to have to find f inverse, and then we're going to have to plug it into g inverse, which means we have to find g inverse. So let's find that. Before we do that, though, as a reminder, on any linear function, let's call it k of x. Let's say that it's ax plus b. We've already figured out that, hey, the inverse of k of x, so k inverse of x, is just equal to x minus b over a. So, or 1 over a quantity x minus b. So keep that in mind because it's a fast way for us to find those inverses of linear functions. Let's use that and apply it to here at g of x. So we know that g inverse of x has to be x minus 7 all over 2. Likewise, f inverse here can just be written as x plus 5 over 3. And you can prove this k of x example to yourself if you need to do that. So anyway, I've got my f inverse, I've got my g inverse, so I can find at least the right-hand side of this by taking f inverse and plugging it into g inverse. So that's going to be this guy right here is going to go into there, and let's just work that out. So this is going to be my g inverse of f inverse of x. And that is going to be, in this case, let's see here, x plus 5 all over 3 minus 7, and this is all over 2. Multiplying the top and bottom by that 3 gives us a final answer on this side of x plus 5 minus, and here, I'll do this over here, multiply by 3 minus 21, that's all over 6, or x over 6 minus 16 over 6. Okay, so that's my function. So that's an equation. Now, if I wanted to, I could factor out that 1/6 so I could see it as a slope, and this would be minus, sorry, let me rewrite that one more time there. 1/6, and then it would be quantity x minus 16. Okay, I'm going to box that. That is the right-hand side. Now we still have to go back to that left-hand side, and in this case it says, let's find f of g of x and then calculate its inverse. So f of g means, let's take the g of x function, plug it into f of x, and then calculate the inverse of that resulting function. Let's do this over here. I think I can squeeze it in. I'll do this in a different color for us here. So in this case, I'll do this in green. We have g, once again, g of x going into f. So let's just calculate f of g first. And that's going to be 3, 2x plus 7 being substituted for x minus 5. So 6x plus 21 minus 5, or 6x plus 16. And that is our function f of g of x. Now remember, this is also linear, so we can very quickly find the inverse of that, and that would just be x minus 16 all over 6, which does match exactly what we have, so we're good on that one. Okay, so that's how you would do this with a couple of linear functions. So it's a lot of work, but because linear functions have such a quick inverse, we can kind of calculate that in our head, which helps us in the process. Okay, I hope this helps on the worksheet. Good luck.